Good afternoon, everybody. First of all, I would like to thank you for having me today. My name is Zulfahmi. I am from the Graduate School of Engineering, Gunma University in Japan. And today I would like to present our research report, especially related to computational forensics. And as you can see on the screen, the title of my presentation is License Plate Reading from a Low Resolution Image. This is the basic outline of my presentation. First of all, we would like to elaborate more about motivations or the reason behind our research. And after that, we will go to the proposed method and experiment, especially in the laboratory and in a real environment, and finally, conclusions. Okay, we go to the motivations. As you know that recently in many modern cities, especially many modern cities, surveillance cameras are often installed in certain places in order to monitor the surrounding activities. If a crime happens, for example, a robbery or even a murder, surveillance camera becomes very important, very crucial criminal evidence, especially because the recorded we can observe thoroughly the recorded data even after the crime happens. So, in this time, surveillance cameras become a very crucial point for further investigations. And in some cases, cars are often involved in criminal. And a license plate on the car can give crucial information, especially to give unique data for further identification. But unfortunately, the image of license plate is sometimes very small and in not readable size. I'm sure that it's very difficult for us to directly read or to even understand what is actually written on this plate. So it is reasonable for us to apply image processing techniques in order to reveal or in order to read what is actually written on the license plate. And the problems getting more difficult, more challenging, especially because we only have very limitations of input image. For example, we got only one single still image and very low resolution. Based on the stated problems, actually the main issue is located on how we are going to recognize the input image. That's very low resolution. And we apply some certain image processing techniques here so that we can get an output of high resolution image that can be recognized by human eyes. And intuitively, or we may think naturally that by increasing the quality of low resolution image, by increasing the input image, we will get a higher output that might be recognized by human eyes. Based on that idea, some scientists propose super resolution image reconstruction. And the technique is actually produce a high resolution image from multiple of low resolution image within same scene. But unfortunately, as stated in the previous problem, since we only have a very limited number of input image, the method faces difficulties when dealing with non-multiple and low resolution image. So, in order to address the problem, we would like to solve the problem within different approaches. We tackle the problem by directly using the low resolution image and do the similarity comparison between low resolution image with some other groups of reference images within low resolution image. And finally, we got the estimation number as our output result. So instead of applying a complex method to refine the quality of low resolution image, we would like to simplify the calculations by doing this similarity comparison. And by using the fact that actually the characters on the plate are among 10 possible numbers, for example, from 0 to 9. So it is applicable for us to compare each character on the plate with 10 possible answers. So in this case, please pay more attention on the last characters on license plate here. So the numbers that's written here must be numbers between 0 and 9. So that's why we do the similarity comparison within low resolution images. So based on this idea, we propose our method. And this is the general or the overall procedure of our proposed method. To make it easier to understand, I made it in blue, in green, and also in green color. First of all, we would like to explain about the input image or target plate in the left-hand side. First of all, we got one still image that is captured by a suspected car, and we call it target plate. So in order, since the purpose of our method is to achieve good recognition, good reading, good estimations on the license plate, so it is reasonable for us to manually cut out the license plate. And since we did the experiment on the Japanese license plate, so we will get 4 individual characters. That is, we call it as original images. And after that, after obtaining the original image, we then compare with groups of reference images. Before we get the reference images, we need to go one step backward, that is, say the reference plate. So in this step, we define reference plate as a replication of a real license plate within the 10 possible answers. That is 0, 1, 2, 3, 4, until 9. And one thing that we have to assume is we apply or we adopt the same circumstances within the suspected car or the suspected criminal when it's happened. So we apply as close as possible the conditions when crime happened. And we also, by implementing the same camera, this is also necessary because in order to get similar imaging resolution. And after that, we take several reference plates and we cut out them, and we got the reference images. And after that, we do similar calculation and got the number estimation as our output. Next, we would like to explain detail about how we make the reference images. First of all, we prepare 10 reference plates that is contains possible answers from 0 until 9. And then reference plates are placed in similar circumstances as close as possible to the investigated condition. For example, in the shown picture here, there's a captured image from the surveillance camera. And then by implementing the same camera, we put the 10 types of reference plates on the car or any other object that resembles as close as possible with the captured image, the captured scene. And after that, we take several kinds of images in slightly different about positions and also orientation. And then we got multiple reference images that's created from each reference plate. This is groups of reference plate for number 0, 1, 2, until 9. Maybe here you have a question that what is the necessary? Why multiple productions of reference images is necessary? This is because a small shift of the characters or a small movement of the characters leads to a different image pattern. So as shown in the picture here, even though we are seeing absolutely same characters, but in the case of low resolution image, it might look different. For example, if we take more attention on this part, let me zoom in. So this is actually we're showing as 1 pixel in an image. So the value of one image, the value of 1 pixel is actually determined by the composition or the percentage of white portion and also the black portion in one single pixel. And if a shift happens, for example, to the right-hand side, we know that the portion of the white portion is greater than the black portion. And if this happens, this phenomenon happens to the entire image, in one frame, of course it will lead to a different image pattern. So that's why in order to tackle this problem, we create multiple productions of reference images. By implementing small variations in position and orientation, we may expect that among the multiple reference images would give the closest similarity to the investigated image. Next, after we got the reference images and also original image, we go to the final step, is the similarity calculation. Number is estimated by implementing the NCC, or normalized cross correlation. So the NCC is computing this degree of similarity between original image and also reference images. And after that, each NCC value that is calculated from all the reference images, we select the maximum NCC value. And reference images which has the maximum NCC value is then estimated as the correct number for our program. So some of you might already know better about NCC. Here is the formula of NCC, and the basic thing is if the NCC value is near to the -1, it means that both characters or both images are probably different. But if the NCC value is near to +1, it means that both images look alike or might be similar. This is actually what exactly happens behind the calculations. So the original image here is compared one by one with reference images by implementing the NCC, and we got numbers of NCC values. And then we sort them within the maximum value here. From character 0, we got 0.21, and after that, we pull out the numbers which has the maximum NCC value here. And we also need to consider the second largest, or the second highest, and also the third highest value. So at this step, we estimate that the final answer for this original image or this input image is probably number or character of number 2. But sometimes there is mismatching or error matching. So in order to solve the problem of error matching, we also need to consider the second highest value and also the third highest value. In this case, sometimes the correct answer is not located on the first highest value. Sometimes it's located in the second or in the third. And that's why in our report, we use the terms of first candidate, second candidate, third candidate. It means that the true answer is located in between first highest, or maybe second highest, or third highest. Next, we would like to go to the experiment in the laboratory and real environment. So the purpose of experiment, especially in the laboratory, is actually to investigate the potential of the proposed method. So by implementing or by conducting experiment in the laboratory, we would like to observe the performance limit under ideal circumstances. By conducting this experiment, we would like to find what is actually the best, the performance limit of our proposed method under ideal circumstances. This is what is actually we got from the laboratory. We have camera and also automatic moving stage here within a constant distance between camera and also stage, and also constant illumination because we did it in the laboratory. And after that, we put plate here, 3 by 3 millimeter, and also as well as reference plate on the automatic moving stage. And the methodology is explained in this slide. That is, the camera is start capturing sequence of images. And if you see here, this is a plate, and in the middle is a number that is printed on a plate. And we move the automatic stage within an interval of 0.1 millimeter to the right-hand side, downward, and maximum of 0.8 millimeter. So actually, for example, 0, we move it 0.1 millimeter in the interval after 0.8 millimeter, then go downward, and then backward of 0.8 millimeter. Why 0.8 millimeter? Because from the previous experiment, it shows that 0.8 millimeters is exactly equal to a shift of the movement of 1 pixel. So this is actually related to the reason why we have to make multiple reference images in our proposed method. And finally, we got the result that the experiment with various distance, when the distance between camera and plate is 62 centimeters, we got all numbers can be identified correctly. And the size of the original image 4 by 7 pixels, and reference is 6 by 9 pixels. But unfortunately, when we increase the distance up to 65 centimeters, we got error for the first time. So we may conclude that this one is performance limit of our proposed method under the ideal circumstances. If we set the original image is lower or smaller than 4 by 7 pixels, we will get error for number estimation. So what actually happens? What is actually error that happens on 4 by 5 pixels is explained in this table. The true number is 0, 1, 2, 3, 9. The number of samples is 1. And we got error for characters 1, 4, and 5. So the first candidate, or the first highest NCC value for character 1, 4, and 5 got error for about 1 to 2%. So we can increase to 100% correctly estimated by the proposed method for the second candidate. So for character 1, we can improve the accuracy by within the third candidate. It means that the true answer is located within the third or second or first maximum NCC value. The true answer is correctly estimated within the third highest maximum score or within the third candidate. That's all for the experiment in the laboratory. So we go then to the real environment since we discovered that 4 by 7 pixel is the maximum or the limit, the performance limit for our proposed method. So we conduct the experiment in a real environment by implemented some parameters we got from laboratory. So we could using a plate, a cargo plate. This one to into a car, and then count out the numbers of the character part, and also we also conducted experiment with another 10 types of original code. Then, within a little bit the same position with original one and also different one, we put 10 possible answers into the card and take several pictures. And here we did the experiment inside the university area with an image of 4 by 7 pixels and breaking 6 by 9 pixels. And here's what we got in our experiment under real environment. As you can see on the table that the characters do give the highest accuracy of estimation, but unfortunately character A is slightly difficult to understand because within the first candidate it just goes to 67.5%, but we can increase up to 88% by third candidate. As you can also see on the graph here, character A is very low in the matching result. So we may conclude that the character who shows the not accurate estimation result. And in general, for example, if we take more attention on the third candidate, the proposed method works around 90%, almost 90% correct, except for character 8 and 9. The numbers are correctly estimated and when we consider the third maximum similarity value. So, in the case of forensic, computer forensic, even if we cannot give a unique estimations on the number, but at least we can narrow down the probabilities up to about 81 probabilities for the numbers that we grade on forensic. So the conclusion is, start from the problem of how to read the license plate from low resolution image. We propose a method to perform license plate reading from low resolution images, where the input image within a very limited number. And we investigate that the performance limit of our proposed method is 4 by 7 pixels, and we confirm that the method works reasonably well under real environment. Thank you for having me here.
Question? What's your question?
Yeah, giving a question. It's about the application because you mentioned that since it's a Japanese number plates, you know where the 4 digits are, but you probably can't recognize the city name or etc. So, did you consider using other information like this, also the car visible in the image? So, if you have the database of the, or access to the database of the number plates and you know to which car models they belong to, did you consider doing some filtering from that?
Actually, by revealing the numbers of, for example, you can at least narrow down the possibilities of suspected cars. And since we got the input image, we can also characterize the car from the input image. And after that, we narrow it down to probabilities with the numbers that's given on the plate.
So, because if you have like 3 possibilities for every vector, this is like 3 times 3 times 3, so for already about 80 different numbers that could happen. If you are considering different cities, it's already large. My question is whether this, at this stage, this kind of system is practically useful for police forces. Did you get some feedback from the client maybe or from the whether, so what is still needed to that they actually want to use it?
Actually, this proposed method already asked by policemen,
Yeah.
local policemen.
Mm-hmm.
And when they implemented the proposed method, it's still difficult for us because we consider about camera that's angle.
Yes.
So that's a little bit difficult in our proposed method since in this method we about
Same
yeah,
level.
almost same level of angle. So at that time, that was a little bit failed for our proposed method, but in this case, for the third time, we have almost 90%.
It's very interesting word.
One question for here, the 90% is about one page or the claim. Okay. Means all items or just one page, one number.
This is actually for 100, for the true number of 0
And
and
you have the hot accuracy for one column, one page, includes 4 digits.
So, this is what